have Professor Robert Dottin as our guest speaker today. In reading his bio, he is certainly a track record of achievements from his scholarship and excellence. And we're certainly honored that he has found it fit to fit us on his busy schedule. Professor Robert Dottin is a professor of biology at Hunter College at the City University of New York. His main area of expertise is in genetics, and he teaches courses in genomics and bioinformatics. Dr. Dottin's research focuses on gene regulation and signal transduction, how genes are turned by extracellular signaling molecules, such as hormones and other factors. For more than 20 years, he has managed the Gene Center at Hunter College, funded by the National Institutes of Health. Dr. Dottin also managed collaborations with nearby Cornell Medical College and Memorial Sloan Kettering Cancer Center in translational research, funded by the NIH. Professor Dottin is a graduate from the University of Toronto, ranking first in the university, and did his MS and PhD at that university. Dr. Dottin he did postdoctoral research at the Massachusetts Institute of Technology. He was a professor at the Johns Hopkins University. He also did research at Oxford University in the United Kingdom, the Pasteur Institute in Paris, France, Karlova University in Prague, the University of Copenhagen, Denmark, and the University of Trinidad and Tobago. His lifelong educational focus has been on the education of minorities in science. His kids, Melissa and Gareth, are now young adults. I must say that he is from Trinidad and Tobago. I know this makes our very own Vivian Valentine very happy. She has relatives in Trinidad. And it is my great pleasure to introduce Dr. Robert Dottin.
Thank you for this warm welcome. It's an opportunity, great opportunity to talk to my friends in Mount Irving. I live in Irvington, not far away from here, and I've been here before, having lunch with you, but it's nice to be back in this capacity as well. I'm going to talk on something that may appear technical, but it's not. It's relatively simple, and I'm sure that you'll be able to follow. This area of genetics has a lot of social implications, and it has that. And first I'll tell you a little bit about the history of how it's come about, and then I'll tell you more about the future. So I'd like to begin with an acknowledgement to the people who lived here before. Those were the indigenous people. And this area that includes New York is called Lenape. And the whole area, which includes Canada and the United States, is called Turtle Island. And so if you'd like to join me in making this acknowledgement, I'd be grateful. We acknowledge the sacred land on which we live and work. For thousands of years it has been the traditional land of Lenape. This place is still home to many indigenous people from across Turtle Island, and we are grateful to have the opportunity to flourish in this land. We are beginning to recognize that indigenous people have endured extreme stress, despite being married and their children. Thank you. So these acknowledgements are quite common. I lived in Canada for a long time, as you know, 10 years. And now, not while I lived there, but now they've become more enlightened, and they've begun to make these acknowledgements in every public meeting. And that's a good start. It's not a solution to reconciliation, but it's a good start. Um, so, this is kind of a summary in a way of some of the questions that you might have about genetics, because many people are familiar with family trees and genetic trees like this. This one is from The Simpsons, and we have Abraham. The one question often among people is where their ancestors came from. And you'll see the answer to these things later on. Does he have Norwegian ancestors? Does he have a gay gene? Can Bart's DNA implicate his distant relatives in some crime? And you've seen examples of this already. Can Lisa's stress or addictions, if any, affect her offspring? What determines Marge Eichel? How will knowledge of Patty's Parkinson's disease affect Selma's plans? That's Selma, and here's Patty, to have another child. And how can we determine Ling's paternity? These are questions that we'll address to a certain extent. And if you have any questions, please, there's some cards there, just write them down, or comments. Of course, you can raise your hand as well and ask it. So, just to begin briefly, a lot of what we know now about genetics it was derived from much simpler times when people made observations about how, as one species might evolve, the differences that we see between birds in one island and finches in another island. That's what one of the things that Darwin did. And he postulated that they must have evolved, even though there are differences on one island with the finches, and in another island where there may be more nuts. The finches have stronger beaks to break the nuts. And those kinds of changes seem to be adaptations to living in different environments. But they were adaptations that were heritable. In other words, it could be passed on to the next generation. And so he concluded that these things must have come because the variants are arising in all these populations, but in populations where having a strong beak is good, that might help those people to survive, or those birds to survive. And in another island, some other feature might help the others to survive, while the others were eliminated from the population because of competition for food and so on. So this was Darwin's contribution, and it basically says, to use a phrase from that Spencer had coined, it meant that it was survival of the fittest. You probably heard that phrase a lot. So now, it's been misappropriated to talk about capitalism and other kinds of activities, the dog-eat-dog world and this kind of thing. But this was one of its applications. So, Mendel provided, from his studies, information that the way in which these heritable traits could be passed on was in genes. He didn't really understand what a gene was, but this was from his experiments. He proposed that these units of transformation could be transmitted from one generation to another, and some genes are more dominant than others. As soon as these theories arose, people began to misappropriate them. As you can well imagine, even Darwin's cousin, whose name is Galton, started saying that this might be a way in which humans can improve their own evolution, not just observe the evolution of other species. And he was always trying to be much more popular than Darwin. And so he proposed these theories. He was a mathematician. They went around measuring people's noses and heads and so on to say that, and he was sort of an elitist. So he noticed that he claimed that poor people who lived in his society had these big differences, and they would always breed and produce more poor people. And then he thought this was a genetic trait, of course. Didn't have anything to do with the fact that they were starving them of any resources. And so that he developed this theory called eugenics. Eugenics was very powerful, and of course reinforced by their own phony observations. And he ignored the fact that, say, normal parents could produce defective children, or that ordinary families who were not elitists could produce geniuses. So these contradictions they never bothered addressing, but he had advocated that we should just use eugenics to, say, prevent poor people and those people who were never doing well from breeding into the next generation. And that was called positive eugenics. However, soon, and that became very popular throughout Britain and the United States. And they held conferences about this. Winston Churchill was one of the major advocates at that time, the president of Harvard, and a lot of prominent people got involved in eugenics. It became widespread in the United States. Charles Davenport, formed the Eugenics Record Office, which is in Cold Spring Harbor, New York, on Long Island. And now it's a world-renowned center for real science in molecular biology and genetics. But in that time, it was used to, again, take measurements, height, and your status, and so on, and try to make theories about how you may improve the human race by using these procedures. So here are some of the characters who were involved. Many of them are familiar to you. Harriman, Carnegie, Alexander Graham Bell, Woodrow Wilson, the head of the American Museum of Natural History, and many universities, Harvard, Yale, the University of Virginia was a major center. And so eugenics became very well, and every university wanted to have a eugenicist on their faculty. And to promote selective breeding. Sterilizations came later, but that's a form of what's called negative eugenics. Now you're preventing people from, that you consider undesirable, from breeding, and in many cases forcing that sterilizations and so on. So positive eugenics first arose, and then negative eugenics followed. W.E.B. Du Bois, or Du Bois, as I would say, was one of the advocates, the NAACP. And there were many racist immigration policies that resulted from this kind of misinterpretation of genetics. And you can hear this even today. One guy just read, after complaining about the kind of people that we were importing into this country, said, bring more people from Norway instead. And I'm sure you can recognize it. This is a map that shows you the distribution of places in the United States where eugenics became very well established, and there were sterilizations. A massive 20,000. Democratic California was at the head of the list, with lots of sterilizations taking place. And of course, these were not an individual deciding that they wanted to have their tube side or anything like that. This was a case in which it was compulsory. And on the other side, the positive eugenics, they had better babies contests, where beautiful kids and so on by the criteria of what's beautiful were used to establish and to promote. Even the NAACP was involved because they thought that this was they got money that they could use in their anti-lynching programs. So, some of you might have heard of Buck, Carrie Buck, who was the first white woman to be sterilized in Virginia, compulsory. And this went to the Supreme Court, and they voted, the Supremes voted 8-1 that in Buck versus Bell of 1927 to sterilize Carrie because her mother was considered promiscuous and institutionalized for being feeble-minded. Of course, these criteria are very vague. And Oliver Wendell Holmes, who was the head of the Supreme Court, I believe, he said, it's better for the world. 3 generations of imbeciles are enough. So these kinds of, this is the history of our people, the nation, and the world. that took place. And although it may seem a long time ago, I've already cited reasons why these kinds of attitudes exist even today. Of course, eugenics itself disappeared after a while, because Hitler, even while he was in jail, praised California for having over 20,000 people sterilized, and in total about 60,000 American women, many of them African Americans, were sterilized in the United States. And in many cases, people didn't even know they were sterilized. They would go in for an appendectomy or something like that, and would be diagnosed with that. And then, can you hear me at the back?
Yeah.
Oh, okay. They call them Mississippi appendectomies. You go in and they tie off the woman's tubes and then send her home and, without even telling you that that's what happened. In Puerto Rico, that was quite prevalent. And Harvard has since made apologies and so on for its behavior, and this is a slide that shows from one recent conference, which was in 2017, that showed a picture of a slave whose name was Renti. And there are many studies that Harvard has published about their behavior and so on. And anyway, Tamara Lanier has, who claimed to be a descendant, and she has a lot of data to show that she's a descendant of this Renti, and now she's actually suing Harvard. And some of you I know read about this in a recent New York Times about 2 or 3 days ago, in which these pictures were available. You saw that, right? Yes. So one of the studies that was taking place at Harvard was done by Louis Agassiz, and he was a rival of Darwin, and he wanted to prove not only that these features could be passed on easily, but like colors of beans and so on, that Darwin, that Mendel had studied, but he wanted to prove that blacks and white people had totally different ancestries. They were never related. We know now that that's not so true. So the result of that kind of ignorance and abuse resulted in, of course, Hitler's genocide. He based many of his ideas on eugenics programs. The Nazis killed about 275 people who had different disabilities, 275,000 people, who had different kinds of disabilities to prevent them from breeding. And they put them in all kinds of psychiatric hospitals and so on. And of course, we know later that as a result of these actions, they became much more aggressive and started to eliminate Jews, Roma people, who were gypsies, and Slavs, and lots of people who were deemed undesirable, and killed them off. And it was only when the concentration camps were opened up that people realized what was going on. When the Allies went to Germany and opened up the concentration camps, then they realized that how extensive this abuse had been, and what impact it has had on the world. I attended a conference center near Munich with my son, who was very young at the time, and we played chess in the back of the room whenever it was raining, because he had, I promised him that he would have a good time at a scientific conference. So we enjoyed it, because it was chess, you don't have to talk, it just make you move, and then I can pay attention to what's going on. And I lost most of the chess games that way. But so we did that, and when it was not raining, he would go outside with his soccer ball, and the kids from around there would come up and start playing with him.
And then one day he came back and said that he saw this sign, which was in German, in the back, and he asked what it was, and he went and got it translated, and it said, "This is the place where all the people who lived in this institution were killed by Nazi genocide and buried at that site." And since this was a genetic conference, of course, I was appalled that we would be having a meeting like that in this beautiful clustered Östsee in Schwaben, near to Munich, and made a big complaint about it and mobilized many of the American Jews who were in attending the conference with me, and we all complained, and the guy who was managing the conference says, "Well, I didn't know about this when I made the booking, but if, in any case, this is Germany," he said, "and it's everywhere. So I can't do anything about it." And of course, we were very indignant and annoyed. However, now, years later, I feel that we were too righteous about our stance. Because at least in Germany, they acknowledge the kinds of abuses that took place throughout the country. They put up signs explaining what they have done. And they'd also done something like this in Africa before, which was the first genocide of the 20th century was done in Southwest Africa, Namibia, places like that. But so they acknowledged it, and then I asked myself, what have we done about slavery? There's been no apologies, no acknowledgement, and certainly no efforts to kind of reconcile all the nonsense that goes on. So that's something to think about. There are other kinds of course, people with disabilities, for instance, are severely affected by these kinds of, because they were the targets in many cases for these misinterpretation of genetics. And anti-miscegenation laws, and people like Margaret Sanger was a positive eugenicist. And there are many paths that people can assume to take for reconciliation that are now being considered. And we see much more of this kind of discussion taking place now in the public press, as I mentioned to you with the Harvard example, for instance, and so on. So I'm going to shift a little bit to talk about how modern genetics is kind of operating, and to tell you that there is a code. It's like if you're looking at all of the books in the library and you're reading the sentences that has information in it about. In genetics, the code contains only 4 letters, A, T, C, and G. And it goes on and on. There are 3 billion letters in the DNA of your code, of your genome, total DNA that you have, in each one of your cells. If you stretch the DNA in any one cell, it's about 5 feet long. But of course, it's compacted and put into a very tiny cell in the nucleus. Nonetheless, it carries all the information that determines a lot of things about you, why you look so much like your sister, and you don't look as much as your cousin, and so on. And although you have this 98% of the sequence of this code is shared with chimpanzees, right? You must, you're very different from a chimpanzee. That 2% or so in differences in where the code lies can account for all of the differences that human beings share with each other and chimpanzees do not. And by making these comparisons, you can set up an evolutionary tree which shows who begat who, which species were the ancestors, were the common ancestors. We did not evolve from chimpanzees, but chimpanzees and humans evolved years ago from a common ancestor. And that's kind of one of the major areas of focus. For instance, here we're showing you this is the sequence, the A, G, T, and C's, and one human was there, and it continues there and there on the top line until you have 3 billion. And chimps, another human almost the same, except in some places you might have one difference. That could account, and each person has, and this represents about 1 in every 1,300 bases, of these things that are called bases, in a human. These are different from one human to another. But with chimpanzees, it's again a lot of similarity, but 1 in every 100 or so is different. In other words, there are more differences in chimpanzees between humans than there are between one human and another, as always. And so that's one of the ways in which we can find out what's the common ancestor, which the common ancestor diverged about 5 million years ago. And so this kind of analysis is what many people, including Savante Pablo, have done to use to make comparisons on how people evolved, and also how people moved from one geographical location to another. Because you can look at the DNA and find out that the people who now live in Western Europe, most of them came from Eastern Europe, if you compare the DNA. And if you compare the sequences and so on with people who are the indigenous people in North America, you know that they diverged maybe more than 10,000 years ago, and so on. So, let's see. Okay, and one other thing that's significant is that although humans maintain the sequence from one person to another, sometimes you have these little accents, I call them, which are different. And they just, the sequence remains the same, but they have a slight difference added to them from one person to another. These are called epigenetic changes. And that's important because it tells you that it changes the behavior of that person. And so with epigenetics, here's an example. One of the best early examples of this was about stress. And scientists Cowley and King studied in Quebec. This is Quebec in northeast Canada. And there was a tremendous storm. The power lines broke down, and in 1998, people's cars had to be abandoned. Pregnant women walked out of their cars and were exposed to extreme stress. And then this is one of the few things that could be studied because they have collected samples of these people's saliva and so on. And 8 years later, after the pregnant women gave birth to kids, and also 13 years later, 36 of the kids showed these marks that I just talked about, these epigenetic marks, when they determined the sequence of their DNA. And they found that they were located at 1,675 Cs that were altered with these little things. So that means that maybe about 900 genes were affected, and most of those genes are involved in immunity, resistance to disease, and so on. But fortunately, the marks after time, from one generation to another, are reversible. They disappear. And that means that there are environmental factors that affect your genes as well. Environmental factors. This is a very important aspect of genetics now, because they can show that extreme stress, like what these people have been exposed to, can change on your genes slightly. So you can imagine what has happened to people who are exposed to genocide, like the indigenous people who lived here, or people who live exposed to slavery, or people who have faced a lot of disasters, especially if they're women who are pregnant. Drug and cigarette abuse can do the same thing, and living in hazardous places like where you live, your zip code, what you're breathing in the air, and so on. And on the other side of it, nurturing and hugging has been shown in rats, where rats lick their pups when they're born. Those pups get different epigenetic marks than the pups that are just left alone. And they know that you can see the behavior of those pups is tremendously different from the ones that don't get maternal care. So genetic sequencing can identify a lot of different variants and it has many applications. In forensics, of course, you can record the state killer. Someone nodded her head when she heard about how to identify relatives who had been killers, and that's how he was found, by looking at the genome. The ancestry, of course, many people know about Ancestry.com and another programs, 23andMe. And you can actually trace that different fragments of everybody's genome has come from Africa. And about several thousands of ancestors have DNA from Africa are in your genome, and that all humans arose from Africa. And some of the small fractions that migrated out of Africa and went into Europe. Some of those people who were in Europe mated with Neanderthals, and they migrated over toward the east, into Eastern Europe and Asia, and down into Australia and places like that. And you can track this just by looking at genomes. Diseases, different people have kinds of diseases respond differently to therapies. People with Parkinson's can easily be identified now in their genome, and it's important for them not to go talking to everybody else in their family, so that who might be affected by, who may not be affected yet. And there are many genome editing technologies now. So to answer some of the questions, certainly Africans, everyone came from Africa. Herbert may have, like everybody probably has some of the genes, gain genes, and there are many genes involved. And now we can see who's implicated in the crime. Lisa's stress is epigenetic and it can affect your offspring. And ICAR comes from many genes, and Ling can be determined by simple testing. And with respect to Parkinson's, it's important to know who's got which. So I think that's okay. So the message: the world won't get no better. We've got to change it now. Just you and me.